Welcome to QuestPond's YouTube channel, and what are we discussing today? Today we are discussing a very important statement. Strings are immutable, right? So what does this word immutable means? So mutable means, things which can change. So when you say mutable, it means it can change, and immutable means opposite of it. It cannot change, right? So what does this sentence means here? So you can see that here's a very simple program I have. I'm declaring a string str, and there is a extremely big loop out here, and this big loop is going and looping till this big value of the number, and whatever is the number value, I'm pushing it into the string, right? So now many people, would think that, okay, this looks very easy to understand. So basically, when the first loop runs, this string will have a value 0. When the second loop runs, so this is the first loop, second loop. In the second loop, you will think that the string will have the value 1. And then in the third loop, you will think that the string will have a value 2, and so on, right? But there is a catch to it. It's not exactly like this. So what really happens internally is as follows. So the first loop runs, loop number 1, and str has a value 0. The second loop runs. Now the previous str value equal to 0 is maintained. It is there internally, and a new str value is created, and in that 1 is pushed. I repeat this. The first value of str which you have allocated, it does not change that. So that means that str is now immutable. It cannot be changed. You want to go and change the existing value, then you create a fresh copy. Now the third loop runs. Again, str equal to 0 is there. Str is equal to 1 is also there. Now he does not change str equal to 1. He creates a fresh copy. Str is equal to 2. Right? So in other words, whenever you allocate a value even to the same variable str, he does not change the old value. He keeps that copy separately and he creates a fresh copy. That means the previous values of the string are not changed. So that's why a lot of people say that strings are immutable. They don't change. So now we would like to go and actually see this. Does it really happen? Like, it's something which is, can we see with our eyes all this, right? So yes, let us see. So I'm going to go, you can see this is my program out here, right? So now let me go and run the profiler. So you can see here there is something called as a profiler in Visual Studio, which helps us to give an insight of what is happening with our application. So I will go to the profiler and let us look into the memory usage. So if the memory usage is increasing, that means what I'm saying is right, isn't it? I repeat this. If the memory usage keeps on increasing, that means that yes, there are different copies of string getting created internally, right? So I'm going to go and click on start. You can see our application is running. It is creating internally the objects, and here you can see that it is showing 12 MB of memory, right? You can see that there is a constant memory. So you'd say, hey Shiv, you are wrong. Can you see that it is a constant memory? No. Watch this. So basically, yes, you can see initially there is an increase, and after this, the memory remains constant. But look at those red signs at the top. Look at those red signs at the top. Camera zoom in, right? You can see that red signs at the top says that garbage collector is cleaning up things. Garbage collector is running and cleaning up things. That's why you see the memory constant. But definitely internally, lot of objects of strings are getting created. Remember, strings are objects, and objects are cleared by garbage collector, right? So you can see that garbage collector, this small red sign here, you can see indicates that garbage collector completed. So garbage collector is running, cleaning, running, cleaning. So new fresh objects of strings are getting created and they are getting garbage collector. That's why we see this 12 MB of memory constantly. But definitely internally, strings are creating fresh copies, right? They are creating fresh copies, and that's why so much the garbage collector has to work so hard, to clear the objects, right? If you do like this, for example, there is something called as string interning. There is something called as string interning. For example, if I allocate, let us say, the same value, for example, if I allocate just str equal to shave, or let us say if I allocate str is equal to correspond, what will happen is he will see that, okay, like you are always allocating correspond. So he says that let me do like this. Let me not create fresh copies. Let me keep this word correspond in some global shared variable. And whenever you say correspond, we just refer to that memory location. So we don't create fresh copies and we don't decrease our performance. So if you see here, for example, if I now go and run the profiler, I shouldn't see garbage collector working so hard. I shouldn't see those red signs, right? So I'm going to go and say debug again. Let us say profiler. Let us see what is happening. And I'll say start here. And there it is. You can see it is saying 7 MB. You don't see these red signs at the top. Camera zoom. So you can see that you don't see those red signs, right? What you were seeing previously, right? So basically, strings are immutable. They are very smart. They have a thing called as interning, string interning, wherein if you keep allocating the same value again and again, it just maintains one global value, one global address for that value, and all the strings, refer to that, right? But now here is my question. Why does string create fresh objects? What is so great about creating these fresh objects? Why not just have one value and update to it, right? Why by behavior are string immutable, right? So if you can go down and put down on my YouTube comment down below saying that why in Csharp, are strings immutable? What is the benefit of creating so many copies, and why not just have one copy and update that, right? So let us have a healthy discussion down on my YouTube comment.